So we'll see memory now, and memory is an important part of the system. With CPU we connect memory, input device and output device. These four are the essential element of the computing system. So first of all we'll see memory, and then we'll see the processor. So what is memory and why it is required? Memory is used to store data which is required for processing. It is used to store program. Whatever coding we do, whatever program we write, that program you have to store in the memory, and so that processor will read that program and execute it. The data and program, they are in the form of 8-bit binary number. So processor language is only binary. Whether you write program in C language or in assembly language or in any other higher language, finally it is to be converted into machine language. That is the language which is understood by the processor. The processor understands only binary language. So all these instructions are compiled, your program gets compiled and it is converted into a binary numbers. So those 8-bit numbers are stored sequentially. These are instruction codes actually, and that's why they are called as code. So the program is stored in memory in the form of 8-bit binary number. Data is also stored in the memory in the form of 8-bit binary numbers. So 8-bit binary number means 8-bit means equivalent to 1 byte. So 1 byte means 8-bit binary number. So if your program is of 10 kilobytes, so 10k bytes, always the size of the file or size of the program is in terms of byte only. But 1 byte is equal to 8-bit binary number. So you may have number of memory locations. Suppose here 64k memory locations are there, 64,000. So in each memory location you can store 8-bit number, and in this memory you can store 8-bit numbers as data or 8-bit numbers as a program. So this memory will be divided in two areas. One is data memory and another area is called as program memory. In data memory area, data will be stored which is coming from keyboard or from sensor or from various input devices. So that will be stored in data memory part, and your program will be in program memory area. So two areas will be there. One is data memory area and another will be program memory area. Okay, so we'll see how this memory is built. So what is the main constituent of that memory? The memory is for the purpose of storing ones and zeros. 8-bit number you can store, but it is a binary bit 0 or 1. So 1 bit, to store 1 bit actually you need one flip-flop. The basic element of memory is a D flip-flop, data flip-flop. In this flip-flop you can store 1 bit data. 1 bit data means either 0 or 1. Now here you can give input either 1 or 0 and it will be stored here. If it is 0 you can get 0 here, if it is 1 you will get here 1. That is the truth table of D flip-flop. But to store this data you need clock here. If clock is 1 means clock is inactive. If clock is inactive, then whatever may be the value of D input, either it is 1 or 0, this will not change. Suppose it is 0, it remains 0. If it is 1, it remains 1 if clock is 1. But if you give clock here, that is a 0 signal, low signal. Then if here it is 0, you get 0 here. If it is 1, you get 1 here. And again if clock is 1, then that data will not change. So whatever data is here will not change until you give here a low pulse. This low pulse means logic 0. When a low pulse will come for short duration, otherwise it is logic 1. Always it is logic 1, so that this data will not change. Always it is logic 1 and this data will remain as it is. But whenever you want to store data, you will give a low pulse. a 0 signal for a very small duration, and that time this clock is active, and if this D is 0, you get 0 here. If D is 1, you get 1 here. In this way, 1 bit is stored. So if clock is 0, then data is stored. If clock is 1, then there is no change in the data. So here basically clock is controlled by a write signal which is given by processor. Whenever processor want to store data into memory, it will give a low pulse on this particular pin which is called as write control signal. From processor, data will be given to memory for storing, for writing purpose, but data along with a write control signal is given. This write control signal is a low pulse, means it will go 0 for a very short duration, and during that short duration period, maybe microsecond, the data will be stored in this flip-flop. So if it is 0, you get 0 here. If it is 1, you get 1, provided the signal is 0. Otherwise, the data at the output will remain as it is. If D is 0 and clock is also 0, then that data will be 0. So here 1 is replaced by 0. Similarly, you can read data from this flip-flop by enabling this tried state buffer. If you enable this tried state buffer, you can read this. So this data can be read by enabling this tried state buffer, and it is enabled by using a read control signal. So whenever processor will give read signal, so this data will be read by processor. So it will go to processor. So this is a line where data will come from processor, which will be stored, and whenever you processor want to read, it can give signal read signal 0, and this is enabled, and you get this data here. So if here it is 1, you get 1. If it is 0, you will get 0. So this is actually a point where data is stored. And by using these two control signals, read bar and write bar, processor will manage the read write operation. From processor, data can be stored into memory when write signal is 0. When write signal is 0, that time read signal is 1. And when read signal is 0, that time write signal is 1. Because processor will perform either operation. Either processor will be reading data from memory, or processor will be writing data into memory. So both signal will not be active. Only one signal will be active, either write signal or read signal. And both are active low signal. Means if both are 1, so there is no read operation, there is no write operation. If read bar is 1, write bar is also 1, there is no read or write operation going on. But whenever processor want to write data, store data into memory, it will give write signal 0 and read signal as 1. It remains 1. Read signal will remain 1, but only write signal will be given 0, so that data will be stored into memory. And after some time, suppose processor want to read, so then processor can read that data by giving a read signal 0, and write remains 1. And in this way, you can read data from memory. So read and write, these two control signals are given by processor, and how this processor will generate this signal, it depends on the instruction. If in your program instruction is to write data into memory, so that instruction is decoded and processor will perform the write operation. And if your program contains the read instruction to read data from memory, the instruction is like that, then after decoding, processor will give read signal. Now this there is only one data line, but to the processor. So the processor has a data pin which is bidirectional. Means processor can give data to memory. So processor can send data into memory. Processor can read data from memory. So since it is both direction, so it is called as bidirectional pin. So here this data is given by processor 1. That processor data coming from processor data is 1, you get 1 year. When write signal is 0. Similarly, you can read this data via same line. The processor can send data, processor can also read data. But while reading data, it will read data via this. To read the data, it will give read signal 0. You will get logic 1, and it will go to processor. So this is a line which is a bidirectional line. The data pin is always bidirectional because data will be given by processor to memory, and data can be read from memory to processor. So both way transfer is there. So it is a bidirectional pin. Now that one flip-flop will store 1 bit data, but actually memory location will store 8 bit data. So you will need 8 flip-flops which will be activated at a time. All 8 flip-flops will be activated at a time. So you can write 8 bit data D0, D1, D2 up to D7. 8 bit data in this flip-flop at once. At once you can store 8 bit number. So data pins will be D0 to D7. So through that 8 data pins, data will come from 8 bit data will come from processor. It will go to memory. A write signal will come from processor, so that whatever data is available at this point, that data will be stored here. And whenever processor want to read this 8 bit number, the processor can read this 8 bit number by giving 0 on this line, so that these buffers are enabled and data will be transferred back to processor. So processor can read this data via D0, D1, D2 and D7. So processor will write 8 bit number into memory location, or it will read 8 bit data from the memory location. So what that memory location consists of? It will consist of 8 flip-flops. So 8 flip-flop will make one 8 bit register, and that one 8 bit register is called as one memory location. And in memory there can be thousands of memory location. So we'll see how it is. So this is that 8 bit register, and this is called as one memory location. You can have 1 gigabyte, 2 gigabyte, 4 gigabytes of memory, but basic unit of that memory, one location, will store 1 byte. And you can have 1 gigabytes of location, you can have 4 gigabytes of location. So each location will store 1 byte. Now this is that 8 bit register which stores 1 byte. 1 byte means 8 bit data. So 8 data pins are connected to this each flip-flop. Each flip-flop one data pin, D0, D1 up to D7. So these 8 data pins are connected to individual flip-flop, and this makes a 8 bit register. And through these data pins you can store 8 bit number into this flip-flop, that is called as 8 bit register. And you can also read 8 bit data from this 8 bit register. To store 8 bit data, you can store like this. So 8 bit data will come from processor, write signal will also come. When write signal is 0, the data given by the processor will be stored into memory. So 8 bit number is stored in memory. Similarly, you can read this 8 bit number. The processor can read this number by giving read signal 0. So these two are the basic operations: writing data into memory location and reading data from memory location. To read data from memory location, read signal will be given 0, and then this data will be transferred to processor via data bus. So these 8 pins are called as data bus, and data bus is always bidirectional. Processor can write data into memory location, processor can read data from memory location. So this data bus is bidirectional. Now you can have many locations in the memory. Let's take an example of 8 memory location. There is a memory IC, and in memory IC there are 8 memory locations. So you can store 8 byte of data. In each location you can store 1 byte. And since there are 8 memory locations, you can store 8 bytes of data. This is just an example. You can have megabytes of mega location, giga locations, and like that. Now here one memory location will have 8-bit register is equal to 1 memory location. Now here this is a 8 by 8 array, 8 bit by 8 registers. So each register is having 8 bit and I am having 8 registers. Now here I can store 8 bytes. 1 byte here, 1 byte in next memory location, another byte in next location, another byte, like that. I can store here 8 bytes of data. Now suppose this is 8 by 8 RAM, means 8 memory location only. For example, 8 memory locations are there in this memory IC. So I will have to select location, particular location, and then I can store data into this. There are 8 memory locations. So I cannot write data in all the location at a time. I will have to select one location and then I can write data into that location, or I can read data from that location. So out of 8 locations, I will have to select only one location. To select one location out of 8 locations, as given in the example, there are only 8 locations. So I will have to give address also. Each location will be identified by a unique address. The address for this location, first location will be 0. Next location is 1, 2, 3, 4, 5, 6, 7. If I talk about address, the first location is having address 0. Always address will start with 0 and it will go as the number of locations will be there. So here there are only 8 locations. I will use 0 to 7 address, and that 0 to 7 address is a decimal actually, but you cannot work on decimal numbers, you have to work only in binary numbers. So here processor for this location address is 0, 1, 2, 3, 4, 5, 6, 7. So since there are only 8 locations, 3-bit binary number is sufficient to write the address. By using 3-bit binary number, we can write in the decimal number in the range of 0 to 7. If I am using 4-bit binary number, I can go from 0 to 15. If I use 5-bit binary number, I can go from 0 to 31. So if you increase number of address bits, you can increase this location. So for 3-bit binary number is like this, 000001 and last is 111. So this 3-bit binary number is the address of that location. So what is the address of first location? 0. What is the address of next location? It is 1, 2, 3, 4. And as I told, without selecting the location from this out of 8, you cannot read write. If you want to store data, you have to first give the address. In which location you want to store data. So processor want to store data, but in which location? So processor will give address also. Suppose processor give address 4. So 4 means this one. So this location will be selected. If processor give address 4, then this location is selected, and then you can store data into this location, or you can read data from this location. So first important thing is address, because there are so many addresses, so many locations will be there, and each location will have unique address starting from first location having address 0 to the last location. So accordingly, processor has to give the address. So there is the address bus, and it is unidirectional. So processor will give address on the address lines, and that address line address will be decoded, and then particular location is selected from the memory. Out of 8, one location will be selected, because it will give 3-bit number to any one out of this. Suppose processor want to read data from memory location, address is 7. So it will give address 7. If processor give address 7, So this is address 7. So this location gets selected, and then processor will read data from this location, or processor can write data into this location. It depends on instruction. For reading purpose, instruction will be different. For writing purpose, instruction will be different. So first important thing is address. To select the location 1 out of 8, and then data write or data read will be performed. Now how this address is used? So this is a 3-bit address. You can write address as A0, A1, A2, as we write data lines, data pins as D0, D1, D2 up to D7, 8-bit data lines. Data pins are always 8 normally for memory, D0 to D7. Address lines will depend on the capacity of memory. The memory capacity, if it increases, then naturally address lines will also increase. So here I am considering example of only 8 memory location. So 3-bit address is sufficient, 3-bit binary address. So 0002 111. Now what happens when this address is given by the processor? It first goes to decoder. The decoder will decode this address. Suppose it is 000, then this line will be active and these lines will be inactive. If it is 001, then next line will be active and these lines will be inactive, other lines. Now what purpose these lines will be used? This is called as address decoder. These lines will be used to select memory location. So there are 8 memory locations. So for selection of 1 out of that 8 memory location, you will give 3-bit address. 3-bit address will be unique, 000. The first location will be selected. If it is 001, then next location will be selected. If it is 111, then last location will be selected. So for that purpose, there is the address decoder inside the memory IC. So whatever capacity of IC is there, so there will be address decoder. And since this is example of 8x8, I am talking about only 3 address pins, so that I will get 8 outputs, and those 8 outputs will be used to select 1 register out of 8. So in this way, suppose you give here 1001. The 001 means 1. So this line will be active, and by using this line, the next location will be selected. First location is not selected, second location is selected. If you give address 101, 101 means 5. So Y5 will be active and it will select that 5th location, means 0, 1, 2, 3, 4, 5. The 5th location will be selected. Location whose address is 5. Now exactly memory IC will have this circuit. The memory IC will have this type of circuit, where in that memory IC there is the address decoder and there is a registers, array of registers. So this is an example of 8x8 IC. So there are 8 registers, and each register will store 8-bit number. Each register will store 8-bit number, and you can read or write number via this data bus. So there is a data bus which is 8-bit, D0 to D7. So you can store data into this location. You can read data from the location. But from which location you want to read or to which location you want to write, it is decided by address. So first thing is address. So processor will give address. Suppose processor give address 001. So this 001 is decoded by the address decoder, and it will select this location. If it is 101, then this location will be selected. If it is 111, then this location is selected. Once location is selected, as it is 001, this location is selected, then you can store data into this. So processor will send data on this line and it will be stored in this register. And processor can read data from this location. So other locations are not selected. So you cannot store data into that location. Only one location out of 8 is selected. So same thing happens in our memory. Memory may be 4 GB, or 8 GB or 16 GB. So, but only one location will be selected, and from that one location only 8-bit data will be transferred. Out of 4 giga locations, only one location is selected and 8-bit data is transferred to processor, or from processor it is transferred to memory. So this is purpose of address is to select the memory location. Address is not stored anywhere. Address is decoded and it will select 1 out of 8. So this is a general format of RAM IC. What it consists of? A RAM IC means memory IC will have this type of circuit where there is address decoder inside it. There is array of registers. Number of registers are there. Each register will store 8-bit binary number. And so there is a data bus which is 8-bit. So this 8-bit data bus is bidirectional. It is bidirectional because you can write data into this IC or you can read data from this IC. So it is bidirectional. Whereas address bus is unidirectional because address is given by processor. You cannot give address to processor. Processor will give address to select the one location out of so many locations. So that address which is coming from processor will be decoded and one location out of 2 raised to n location will be selected. So if it is having n-bit address, the output of this decoder will be 2 raised to n. And so you can have 2 raised to n registers in this IC. Decoder means n number of input, 2 raised to n number of output. So 2 raised to n number of 8-bit registers will be there. 2 raised to n 8-bit registers will be there. So capacity of this IC will be 2 raised to n registers, and each register can store 8-bit data. So number of registers, and this is data stored in each location. So that is the IC capacity. Apart from this, there will be read and write control signal given by processor. Whenever processor want to read data from this location, from any one location, it will give first address, it will select the location, then read signal will be 0, write signal will be 1. So read signal will be 0, and so from that you can read the data from the selected location. Similarly, processor want to write data, store data, the operation will be first it will give address, it is decoded, one location out of this 2 raised to n is selected, and once the location is selected you will give data from this side and write signal 0. When write signal is 0, this data will be stored in selected location. Only one location which is selected, and this is enable signal. This is for chip select purpose. If your circuit is having more than one IC, RAM ICs, then you can use chip select signal so that particular chip is selected, and from particular chip particular location is selected. For that purpose chip select signal is there. Now if you look at this table, if you have n number of bit of address, suppose address pins are 8, processor is giving 8-bit address. So what will the capacity of the memory IC? It is 2 raised to n. So this is value of n. N means number of address pins. Processor give how many bit address? If suppose processor is giving 8-bit address, the 8-bit address will be decoded. So that is 2 raised to 8. So 2 raised to 8 means 256 memory locations will be there in the memory IC. The memory capacity will be 256 only. If there are 8 address pins given to the IC, then memory capacity is only 256 memory locations, and each memory location will store 8-bit binary number, that is 1 byte. So each location will store 1 byte. Number of locations are 256. So memory capacity, storage capacity will be 256 bytes only. But if you increase a single line here, address line is increased by 1, then 9 address lines are there. Then 2 raised to 9 is 512. So 512 memory locations will be there. Each location will store 1 byte. So capacity will be 512 byte. Then suppose there are 10 address lines. You are giving 10 address lines to the IC. Then the capacity will be 2 raised to 10, that is 1024. it is also called as 1K. So 1K locations will be there, 1024 locations, and each location 1 byte, so it is 1 kilobyte. So you can store 1 kilobyte data if you have 1K RAM. 1K RAM is there, then you can store 1 kilobyte. Suppose you have 11 address lines, then your capacity will be double. It is 2K, that is 2048. So it is called as 2 kilobytes. So normally we write like this, memory size, whatever file size is there. If you are using Word, Excel, when you save that file, so always you get a size of the file and it will be in some kilobytes. So it is always in bytes, not word or not as a 32-bit number, not as a 16-bit number. Always it is a 8-bit number. So how many 8-bit numbers are there? So that is the size of the file. It can be 2 kilobyte. If address lines are 16, then 2 raised to 16 will be 64K. It is 65,536. So many memory locations will be there, and in each location you will store 1 byte. So capacity of memory will be 64 kilobyte. Then if you have 20 lines, address line, so 20 address lines will be decoded. So 2 raised to 20 will be the output of the decoder. 2 raised to 20, that is 1 mega, and you can have 1 mega memory location. So 20-bit address is given to select one location out of 1 mega location. This address will be unique number, 20-bit number. That unique 20-bit number will be decoded, and it will select one memory location out of 1 mega memory location. And you can store 8-bit number into that location, or you can read 8-bit number. Capacity will be 1 megabyte. If you have 30 address lines, then 30 address lines will be decoded. You can have 1 GB, 1 giga location, and in each location you can store 1 byte. So 1 gigabytes of data you can store, provided a processor use 30-bit address. If processor is giving 32-bit address, now it depends. So when you talk about initial processor, in initial processor like 8085, the addressing capacity was 16-bit. So there were only 16 address pins. So it cannot give address more than 16-bit address. So for 16-bit was the maximum limit. So it was having a memory capacity of 64 kilobytes only. You cannot store data more than 64 kilobytes. But as advanced processors have evolved, so then we have gone for 32-bit processor, then 16-bit processor, 32-bit processor, then 64-bit processor. So that time they have increased number of address line also. The processor can give 32-bit address, it can give more than that also. So capacity will always naturally increase. Suppose processor is giving 32-bit address. The 32-bit address means it is decoded. So 2 raised to 32, it is 4 GB. So 4 giga locations. Out of this 4 giga location, one location will be selected by using this address. And this 32-bit number will be one unique number. It is decoded by the address decoder, and it will help to select one memory location out of 4 giga location. And then you can read 1 byte or you can store 1 byte. That is it. So in these 4 giga locations, you can store 4 gigabytes, because each location will store 1 byte. So 4 gigabytes. What will happen if I increase one more line? If it is 33-bit address, then capacity will be 8 GB. If I go further, I have 34 address line, then capacity will be 16 GB. Now I will observe here, when I increase one address line, the capacity is getting doubled. 256, then 512, then 1K, 2K, then 4K, then 8K, like that. Here 30 address line will have 1 GB memory, 31 address lines are there, you will have 2 GB, 32, it will have 4 GB, 33, 8 GB, and then 34, it is 16 GB. So this is how That's why your pen drive which we purchased, it comes in the form of capacity of memory of this pen drive is in the form of 2 raised to n. Means you can get pen drive of 4 GB, then directly 8 GB, then direct 16 GB, then 32 GB, then 64 GB, then 128 GB or so. Because one address line is increased, the capacity get double. You will not get pen drive of 10 GB, 20 GB or in between. You will get always in the power of 2 raised to n. So it will be 4, then 8, then 16, then 32, 64, 128, 256 and so on. So you will not get pen drive of 10 GB or 20 GB because it is not in the form of 2 raised to n. Now you can take example of a RAM IC with 1K memory locations. 1K memory location means 1024 memory location, and each location will store 8-bit data. So capacity of this memory IC will be 1 kilobyte. 1K memory location, each store 1 byte of data, so it is 1 kilobyte. Now what will be the structure of this IC and how many address lines will be there, how many data pins will be there? The structure is as it is, only difference will be in this address line. How many address lines will be there? So since its capacity is 1K, the address lines will be 10, because 2 raised to 10 will give you 1K outputs, 1024 output. If the capacity of IC is 2K, then you need here 11 address line. If capacity is 4K, then you need here 12 address line. So these address lines will keep on changing. It depends on the capacity of IC. Since the capacity of IC is 1K, address lines required is 10. So 10-bit address is required to select one location out of this 1024. So processor will give 10-bit address, and the 10-bit address is decoded, and one location out of this 1K is selected. And from that selected location you can read data via this data bus. Since data is 8-bit only, you can read data via these 8 data pins. You can write data also into this location via these 8 data pins. So data pins are bidirectional. Data can go to processor, means processor can read data from memory, processor can write data into memory via these lines. Address is also given by processor. So first step is address. Processor will give 10-bit number, which is the address, and accordingly one location is selected out of 1024. Then to read data from this location, it will give read signal 0, write signal 1. So since read signal is active, you can read data via this data line. The processor will read data from via these data pins D0 to D7. Similarly, to store data, processor will give first address. It will select the location, one location. Data is also given. Then write signal is given 0, read signal is 1. Since write signal is active, data will be stored into location in the selected memory location. This is how data read-write operation is performed from the memory IC. So memory IC will have this circuit which consists of address decoder and register array. A set of registers will be there. It depends on the capacity of IC. And read-write control signal unit will be there, and the data pins will be there, address pins will be there. So this is normal structure of a RAM IC. Suppose RAM IC is of capacity 64K. The 64 kilobytes data you can store in this IC. But to select one location out of 64K, you will need 16 address lines. So 16 address lines will be from A0, A1, A2 up to A15. So A0 to A15 address lines will be there, on which address is given. It is decoded and one location is selected. And then you can perform the read-write operation by using this control signal. And data will be transferred via data line. So two lines are separate. Address line bus is separate, data bus is separate. Address bus is unidirectional because address is given by processor. and you cannot give address to processor. So address is given by processor, and data can be stored into memory, or processor can read data from memory, so it is bidirectional. So always there is a data bus which is always 8 bit, always 8 bit. Address will depend on the memory capacity, and it can be 16 bit, 10 bit, 11 bit, it depends on the capacity of the memory IC, and there will be 2 control signals. So this is how the memory structure is there, and that's about the memory. So we will see in next lecture further regarding processor. So here you can store data, or here you can store program, but that process, how processor execute the program, that we'll see in the next part. Thank you.